Okay, so we've got our notebook out, and we're going to take notes today on solving two-step equations. Division. One of my rules when we're taking notes is that if I write it, you write it. So right now you should have two-step equations, division, and the date in your notebook. Okay. We're going to go over some of the same things we've gone over before, but I want to make sure that we understand what we're doing. Not just doing it, but understanding what we're doing. So we're going to use an example. X divided by 7 plus 5 equals 12. So that's x over 7 plus 5 equals 12. So if you remember, my thing is always to separate the two sides to make sure that I remember that they are equal and separate. So I draw a river. Some people draw a wall. Some people do whatever you need to do to separate the two sides. It's really important that we're able to see them as separate. Okay. So if you remember, our goal is to get x alone. And when we're doing equations, we're going to reverse PEMDAS. So what that means is we're going to start with adding and subtracting to get rid of things that are near the x. So we need to get rid of this plus 5. The way we undo addition is through subtraction. So we're going to subtract 5. And because we have a balanced equation and we want to keep it balanced, we need to do it on both sides. Okay. So now we look at everything that's on this left side. X divided by 7 plus 5 minus 5. We can say plus 5 and minus 5 are going to cross each other out. They cancel out to 0. So we're just going to bring x divided by 7 down and our equal sign. And then 12 minus 5 equals 7. Okay. So the next thing we can get rid of has to do with multiplying and dividing. Now, I want you to take a second and think, what is going on between the x and the 7? Are they adding, subtracting, multiplying, or dividing? The x is being divided by 7. So the opposite of division is multiplication. So we're going to multiply the left side by 7. It's a horrible 7. And we're going to multiply the right side by 7. Both sides get the same thing because we have to be fair and square, even Steven. We have a balanced equation. We need to keep it balanced. All right, so 7 divided by 7 is 1. So we have x equals 7 times 7 is 49. So that is our solution, but we know we're not done because the next step is to check. So we're going to take this equation and bring it clear down here. And we're going to say x over 7 plus 5 equals 12. Part of our check, we're going to substitute the solution for the variable. And what I mean by that is we're going to take our 49 and we're going to put it where x is. Okay. Oops, sorry, that needs a 4 there. Let me give you a second to catch up with me. I know sometimes I go too fast. Okay, so we're going to substitute in 49 for the x. So now we have 49 over 7 plus 5 equals 12. Then what we're going to do is normal PEMDAS. So we're going to multiply or divide first. Okay, so we have a division right here. So 49 divided by 7 is 7. And we'll bring down our plus 5 equals 12. Then we can add or subtract. So we have an addition set right here. 7 plus 5 is 12, which equals 12. That is a true statement. One thing I want you to notice is that this 12 stays the same. So there's never a change on this side. Now, that feels like a rule that we will change because at some point the constant may be on a different side. But for these equations, when we have a single constant on the right side, that number is not going to change in our check. Okay? I'll leave that up there for a moment so you can see the whole page, get your notes caught up, and then I'll answer questions.